Hi everybody, and welcome to our second unit, which is about the oceans. So I'm wearing my Planet Earth shirt, and we are known as the blue planet. We've got a lot of water on our planet that comes in the oceans. So the first thing we're going to talk about with oceans is seafloor features, which kind of goes right along with what we learned for plate tectonics. All right, Swabat. Students will be able to describe and illustrate seafloor structures. So our oceans make up 139 million square miles. So it covers up a ton of our Earth. And this is just going to be a quick review for oceanic crust. So we just want to remember that it's the layer of crust underneath the ocean, and it separates it from the mantle. And that it's different from continental crust in a couple of ways. It's thinner, it's more dense, and it's younger. All right, so here we're going to start talking about seafloor features, like what is underneath the ocean. Now, a lot of us, when we think about the ocean floor, we just think that it's like this flat, like football field-ish kind of, it's just flat down there. And that's actually not really the case. So the first part of the ocean floor features or seafloor features is called the continental shelf. And basically, if you've ever been in the ocean, this is the part that you're standing on. It's right next to a coast, it's right on a beach, and it's really pretty shallow and flat. And it's still part of actually the continental crust. We are really not yet on the oceanic crust, even though we're under the ocean. So that's the continental shelf. So think shelf like a bookshelf. It's pretty flat. The second part is the continental slope, and it's basically, we get a drop off, and it's a steep drop off that descends toward the floor of the ocean. This is also still part of the continental crust. You can see the continental crust right here, and the slope is still on the continental crust. Next, so the abyssal plain is the flat air of the ocean, and it covers more than 50% of the Earth's surface. So a lot of the ocean floor is this flat area called the abyssal plain, and that's kind of typically, as I said earlier, what we think of when we think of what the ocean floor looks like. A plain, if you think of like geography or like the plains of the United States, is kind of a flat area, and so that's the same thing for abyssal plain, the flat area of the ocean. The next thing that we're going to talk about is a mid-ocean ridge, and we've actually talked about this before in our plate tectonics or plate boundaries unit, where this is where we've got a divergent plate boundary and we've got new crust being formed, but we get this underwater chain of mountains. And we kind of have several peaks of these mountains, but because the crust is coming up and then it moves forward, and so we get this big chain though of mountains under the ocean. And then mid-Atlantic ridge is a real world example of where we've got this huge chain of mountains underneath the ocean and a divergent plate boundary. So it's called a mid-ocean ridge. The next thing we've also talked about during plate boundaries, and it is a trench. And in a subduction zone, we get this lip of one side of the plate boundary that's getting pulled under, and we get this long trench where it's usually very deep. So think of like dragging a stick through the dirt, and we've got this trench, so it's deep. And so the Mariana Trench is such a trench at a subduction zone, and it's actually the deepest part of the ocean. All right, something else we haven't talked about, we've talked about volcanic islands, but a seamount is basically a volcanic mountain that's not broken the surface of the water. So it's still underwater at this point. So they're made up of the same thing, a volcanic island and a seamount. It's an underwater mountain formed with a volcano. But a volcanic island is now above the water, so we have an island, right? The island is above the island or above the water, and the seamount is still underneath the water. It hasn't broken the surface. All right, so here we've got kind of a picture that shows two different continents. So we've got the shelf, the slope, abyssal plain, seamounts and volcanic islands. mid-ocean ridge right here, a big trench, and then we kind of go back up to slope and continental shelf again, showing on the other side of the continent. So of course this is a very condensed image of what it looks like under the ocean, but those are the seafloor features that we are learning about. So how do we know this? Much of the ocean has not been explored because it's very difficult for humans to explore the ocean. So how do we know what's down there if we haven't been there? And the answer to that question is sonar. Sonar is sound waves that are emitted from the bottom of a boat, and it's basically like echolocation. So there's a device on the bottom of a boat that releases some sound waves, which are in red in this case, and they hit the bottom of the floor, and when they hit the bottom, they are bounced back up. So these blue lines show the bounce back, and they can use how long that takes to measure how deep it is. So basically these boats have been measuring depths, and then they can chart it on a map. And using those depths, they can tell if there's like a mountain or if it's just a deep abyssal plain or what it is. So the first map of the ocean floor was in 1843. I actually have a copy of this map in my classroom, but this is the mid-Atlantic ridge right here. And it's this big underwater mountain chain, but you can kind of see where there might be flat areas, where there might be volcanic islands. And so that sonar helped make that map. All right, reflection questions. What seafloor features are still on the continental crust versus the oceanic crust? What seafloor features happen because of a subduction zone? Maybe you can look back at your notes and look at what seafloor features happen as a result of a subduction zone. What seafloor feature happens at a divergent boundary? How do we know what's at the bottom of the ocean? What technology do we use to see what's on the bottom of the ocean? And I want you to think about, this wasn't really in the notes, but why would it be difficult for humans to explore the ocean floor? Tell me some things, or think about some things that would make ocean exploration difficult for humans. All right, we've got our meme for the very first part of our ocean unit. And just remember, science rocks.